Okay. A lifeguard has 1,000 meters of rope to mark off 3 sides of a rectangular swimming area. Great question. Find the largest possible area. What are the dimensions? Okay, I'm going to draw, let's call it a beach. Okay? We got our beach. And then we have what? A 3-sided rectangular swimming area. Right? We know the perimeter is 1,000 meters because that's how much rope we have. Okay, so I'm still going to label the diagram in such a way that it's still a length times width kind of question, right? So I'm going to put the width up here, and I'm going to have a length and a length here on the sides. Yes?
Do you still have any more of like the sheet with the word problems?
They're there, buddy, I think.
Isn't the perimeter more than 1,000 because it is the beach as well?
Ah, good question. It's 3-sided. What that means is I'm able to better use that 1,000 meters of rope because I don't have to rope off the beach. It changes the question in a way that it's not going to be a square this time. Right? All I've done is drawn exactly as it said. I have a beach, and then I've roped off this kind of rectangular area with 3 sides, and I have 1,000 meters. So it's the exact same question now, with the exception that the perimeter equation is no longer 2L plus 2W because I don't have 4 sides, I only have 3. So I have 2 lengths plus 1W. But that is equal to 1,000. Okay? From there, oh, don't forget I still got area over here. Length times width, right? So from there, I would just isolate for W. So 1,000 minus 2L is equal to W. Now, I have one of the variables isolated. I have another equation up here. Plug it in. Area equals, here, hold on. I don't know where you guys wrote this yet. You're on probably a piece of paper. I'm going to save myself some space here. I'm going to move down here. Okay. I'm just going to make the substitution for W. W is equal to 1,000 minus 2L. So area equals length, and I'm going to make the substitution for W. 1,000 minus 2L. And then I'm going to distribute. It's 1,000L minus 2L squared. Okay? Did I bring my coffee back or no?
Is it in that Yeti mask?
Yeah. Is it not there? I don't know where it is. It's okay. Must be in the math office. Okay. Is everybody okay with that? That's kind of the hard part of the question over, actually. Done. Now what? It's asking me about the maximum area. So what am I going to do? Write it in vertex form so that I can read the vertex, which tells me maximums or minimums, which means I'm going to have to complete the square like on the backboard. So if I'm completing the square, step 1 of completing the square was what? Make L squared by itself. So factor the negative 2 out. Open a square bracket. L squared minus 500L. I can now find the Z value. what's 250 times 250?
Mm,
15,000.
it'd be like,
What is it?
62,500.
yeah.
Oh, not even close. It's Friday. Okay. What do I do with this little number? I'm going to add and subtract it to the inside of the square brackets, right? So A equals -2 square bracket, L squared minus 500L plus 62,500 minus 62,500. Okay. First three create a what? Perfect square trinomial. Then I multiply the two in to both terms inside the square brackets. Now the square brackets disappear, and then you have a nice equation in vertex form. -2 L minus 250 squared plus, here we go, what's this?
125,000.
What am I doing? Is that right? That's right.
Yeah.
Okay. Now, this question asks me what the maximum area is. Is what I've written, how am I going to word this? I'm not good with words. Does this equation have a maximum?
Yes.
Why?
Um,
What direction is it opening?
oh yeah, it hasn't.
It's opening down,
Yeah.
so it must have a maximum. So I know I'm okay. It's good. What is the maximum? What's right the vertex? 250 and 125,000. Okay,
I wonder.
Or you're missing a 0.
it's Friday. That was much nicer though. It was calm. It was good. What's the maximum area?
It's like the Y thing.
It's the Y term. Max area is 125,000. Did they give us units in there? Feet. Can't have squared bananas. What is meters? Meters squared. What's the length dimension that satisfies that? What is L such that the area equals 125,000?
Is it L minus 250?
Huh?
What are you trying to say? Is right?
I'm asking what the length is for the picture. What's the length in the picture up here? See, this, Mr. Lin said this was a point of contention with your completing the squares, interpreting the vertex. L equals 250 because it's a vertex. Here's L. The length when L equals 250, that's fine and dandy. But it asks for both dimensions. What's the width? How do I find the width? Lucas,
2L.
careful. I have an equation to tell me what the width is. 1,000 minus 2L. Don't forget your units.